Dear aspirants, welcome to my channel. This is in model question paper 1. Branch is electronics and communication. Subject name is applied electronics 1 and subject code is 25 ECE 21I. So today I am going to explain 3 marks question. So you will get 15 marks if you attend 5 questions. So pakka you will get 15 marks. Next, question number is define electronics. List any applications of electronics in a daily life. So electronics is a branch of science and engineering that deals with the study and control of flow of electrons in a device such as a diode, transistor and circuit. So this definition you have to write it. Coming to the applications of the electronics, so which we can use it for communication systems, let us example mobiles, phones and internet, and we can use it for entertainment device that nothing but TV, radio, and we can use it for computers and laptops, and we can use it for medical equipment, something ECG and X-rays. So these are the applications of electronics. List any 3 application of LED electronics circuits. So LED or electronic circuits, so that we can use it for indicator lights in electronic devices, and we can use it for display panels, nothing but digital clocks and calculators, and we can use it for traffic signal lights and use it for optical communication system. Next question is explain working of photodiode and mention one example where it is used. So working of photodiode. So this photodiode which is operated, it is based on reverse bias. When a light falling on it, the photons create electrons. Holes pair in the junction. Okay, this generates photocurrent which increase the light intensity. This is the working principle of working photodiode. So coming to the applications, and where applications are example where we have to use. So example and applications which we can use it for optical communication systems like a fiber optic communication. There we can use photodiode. Next, explain the function of base, emitter, collector in a BJT transistor. So emitter, where we have to use emitter, it is a heavily dropped region that emits charge carries. It means electrons or holes. Okay, the use of emitter. Coming to the base, it is thin and lightly dropped region, okay, that controls the flow of carries from emitter to collector. So coming to the collector, it is a moderately dropped region that collects the charges, carries and provide a output current. Next question, describe the input and output characteristics of BJT and CE configuration. Okay, coming to the input characteristics of CE is a current emitter. Well, first one is it is show the relation between base current and base emitter voltage and at constant VCE voltage current emitter, and it is a similar to forward bias diode characteristic. It is having a forward bias characteristics. Coming to the output characteristics of CE, it is a collector emitter. So it shows a relationship between collector current and collector emitter voltage at constant IB, and it is a 3 region. One is a cutoff, active, saturated region. We are using this characteristics configuration of CE. Next, explain why thermal runaway occurs in a BJT and how a heat sink prevents it. In a thermal runaway, in a BJT transistor, it is a temperature increases, collector current increases. The increasing power dissipated cause a further rise in the temperature. When you increase the power, temperature going to rise. The process continues lead to damage of transistor, that is we call it as a thermal runaway. This is the process will be continued. It will leads to damage the transistor, that we call it as a thermal runaway. And how you are going to prevent the heat sink? Prevention using a heat sink. So what is the role of heat sink? Heat sink, it will be dissipated excess of heat to the surrounding, whatever excess of heat which be coming from that it will be surrounded, and keep the temperature stable. When we have to keep this temperature is stable to prevent thermal runaway, to damage the transistor, that you can avoid if you keep the temperature is stable. Next is, in CE amplifier, if collector resistor is increased, explain effect of voltage gain. So in a CE amplifier, okay, collector emitter, in a voltage gains directly proportional to collector resistance. When the voltage increases, directly proportional to resistor. When the RC resistor increased, collector resistor is increased, the voltage drop across it increase from the same current. Okay, it will be increased, the voltage drop, and it also increase by same current, and the result increasing output voltage, which will leads to higher voltage gain. Okay, when you increase the output voltage, so higher the voltage gain. Okay, increasing the collector resistance, based on that increasing the voltage gain. How you have to increase the collector resistor, it should be depending upon the increasing voltage gain. Draw a transfer characteristics of CMOS inverter and explain the region of operator. I didn't write the diagram, just I am going to explain. So in a graph, input voltage and output voltage, so you will get a input voltage and output voltage. When a input voltage is low, okay, so this PMOS is on, NMOS is off, so output voltage is high. Okay, same way input voltage is increased, the both transistor connected, output voltage is decreases sharply. When increasing input voltage is high, NMS on and PMOS is off, and output voltage is 0. So just I have explained only graph, how it will behave. I didn't write that graph. And region of operations, the region 1, low input, high output. In the region 2, transition region, both on output switches. Okay. In the region 3, high voltage input, low output. Okay. If information is useful, please subscribe my channel and share, support, and keep watch my channel. Thank you.